person. Yes, Imad. Imad कहाँ हो? इमाद तो है ही नहीं। गुलमीना आप रीड कर लो प्लीज।
Define the ohm.
So
It
ohm
is
is a
the
unit
unit
of
of
resistance,
resistance.
but you cannot say that. You have to explain it in terms of the units, right? Can you recall the formula that relate the ohms and the other quantity?
Is it the ratio of current and sorry, क्या था?
Voltage and current.
Voltage. जी,
But look, V equals to IR से आप relate करियो, right?
जी sir.
Wait. So you are actually relating it with V equals to IR, right? And अगर आप R को subject बनाओ V over I, okay? So now you have to say ohm is basically volts. Volts, the unit for voltage is volts per ampere. Okay, is that clear? Per ampere. This is the definition. ये आपको याद होनी चाहिए. Okay, Gulmina, is that clear?
सही sir.
अगर आपसे कोई पूछे कि भाई what is the definition of volts, तो आप क्या बोलोगे?
Uh,
It should be
um,
joules. No, joules per coulomb. ओके कूलम यू कैन नॉट यूज दिस फार्मूला अगेन फॉर द वोल्ट्स ओके वोल्ट के लिए हमारे पास वोल्टेज के लिए फार्मूला होता है V इक्वल्स टू V इक्वल्स टू W ओवर Q रिमेंबर दिस इज द फार्मूला
सही sir.
फॉर वोल्ट ओके नाउ ओके आगे
Sir, I
चलिए
have one.
हाँ यस
I had a test, and there's a one question I didn't understand. Can I just send you the photo?
यस प्लीज ओके आगे आ जाओ प्लीज रीड कर लो
A cell X of electromotive force EMF 1.5 volts and negligible internal resistance is connected in series to three resistors A, B, and C, as shown in Figure 6.1. Resistors A and B have resistances 6 ohm and 3 ohms respectively and are connected in parallel. Resistor C has a resistance 4 ohms and is connected in series with the parallel combination. Calculate the current in the circuit.
ओके so for the current in the circuit you have to find the total resistance so can you tell me the total resistance please yes
Same. सर ये 1/6 प्लस 1/3 करेंगे और फिर उसका
yes
सम 4 के साथ ऐड करेंगे ना
yes but you have to do it reciprocal first no so ये हो जाएगा 2 ये हो
तो
जाएगा
6
वन ओवर
ओम
टू
होगा
और टोटल परफेक्ट और so total resistance would be अच्छा 2 ohms right and or for the whole circuit 2 plus 4 gives you 6 so 6 is the total resistance V equals to IR so voltage is 1.5 and R is 6 so 1 za and 4 za 0.25 okay okay please move on
the current in resistor B
the current in the resistor B okay yes क्या करोगे
सर इसमें V आउट वाला फॉर्मूला यूज करेंगे और फिर उसको वोल्टेज निकाल कर फिर हम वो यूज करेंगे करंट का फॉर्मूला
ओके सो वी आउट का फार्मूला आप यूज कर रही हो सो बेसिकली नो ओके फाइन तो अगर आप वी आउट का फार्मूला निकाल यूज करिए तो वी आउट किसके क्रॉस निकालोगे
We can just use a regular formula, V is equal to I R.
यू कैन
Uh, so the voltage will be the same, and this, I mean, it will be
बट
same in
व्हाट
parallel. So,
बट व्हाट विल बी द वोल्टेज विल इट बी 1.5
yeah, I think so.
नो Look, 1.5 is the battery voltage, and some of it getting dropped across AB, and some of it is getting across C, right? So you can say that. So you first have to use a ratio method to find the voltage drop across A and B, right? And then that voltage will be the same at A and at B, right? Look, this you should visualize that circuit into this form, into this form. Okay, so this is 1.5 and this is the parallel combination of A and B, and this is C, right? So the parallel combination of A and B had the resistance of 2 and C has a resistance of 4, right? So they're saying find the current in B, right? For the current in B, we should have this voltage, right? This voltage, and this is not equal to 1.5 because some or most of it will get drop across 4, right? So you can just do the ratio method. So if you have 1.5 volts getting drop across the overall resistance, which is the 6 in the circuit, so what would be the voltage drop at across 2 ohm resistor, right? So that would be 3 over 6 and 1 over 2, 0.5. 0.5. Okay. And the remaining would be the one will drop across here. Okay. Now we know the voltage. We can use V equals to IR now. V equals to IR. Okay. Now the 0.5 volt will be across A and will be across B as they're in parallel, right? And for B, the resistance is given as 3, and so the resistance is given as 3 and the volts is given as 0.5, and we are interested in current, so 0.5 divided by 3, right? So you will get how much? 3
1
point
over 6.
1 over 6. Okay, fine. 1 over 6 is 0.1666, right? Yes, 0.167, right? Clear?
There is this. Can we solve this question using the V out wala formula though?
वही तो लगा रहे हैं, ये रहना वी आउट वाला. आपने ये यूज किया होगा ना, वी आउट
अच्छा बस सही है.
आर डिवाइडेड बाय आर टोटल ना. सो आर टोटल हम आर नीचे आर टोटल आपने रखी होगी इंटू वी इन आपने रखा होगा. सो वी इन मेरे पास आ गया 1.5, राइट? आर टोटल मेरे पास आ गया 6 और वी इन मेरे पास आ गया 2. देखो सारी चीज़ें तो यूज़ कर रखी, राइट? क्लियर
जी
हुआ ना?
ठीक है सर.
ओके परफेक्ट, आगे आ जाओ.
The ratio of power dissipated in resistor B over power dissipated in resistor C.
ओके, so power dissipated in B and C. Hmm. So we can use a formula for power. So power, okay, so current and voltage both are different, right? So for power dissipated, come on, for power dissipated in B, I am using I square R, right? And for power dissipated in C, I'm again using I square R, right? But both all the quantities are different. So I square in B is what we just calculated, which is 1.67 squared, right? And the resistant value is 3, right? And in C, the current should be 0.25, like the total current, right? Because it is in series, right? And you have to square it, times it by 4. Okay, so just solve it.
Sir 0.08.
0.08. Fine. Okay, let's move on.
The resistors A, B, and C in part B are wires of the same material and have the same length. Explain how the resistors may be made with uh, different resistance values.
Hmm. जैसे इसका जो रेशियो आ रहा है दैट इज 0.333, आपका 0.088 कैसे आ रहा
Yeah, 0.334666.
है? इज द रेशियो
जी सर, सॉरी, वो
0.33?
स्क्वायर करना भूल गई।
ओके, फाइन, यस। Explain how the resistance may be made with a different resistance value. You can
सर,
change the
इसमें
dimension. Could you? Yes.
क्रॉस सेक्शनल एरिया भी इनका चेंज कर सकते हैं।
Okay. So you can change the cross-sectional area. You can change the diameter. You can change, like the diameter changes the cross-sectional area. You can change the length, right? So vary the length, the length. Okay.
Sir,
Or
it says length already.
already. Okay. Same length. Okay. Then just use diameter. Diameter. Okay. Let's move on.
Calculate the ratio average drift speed of the charge carriers in resistor B over average drift speed of the charge carriers in resistor C.
Okay. Um. So we know the current in both the resistors, and so I over NAQ should be equal to V, right? Um, it should be more than that, यार. दो मार्क का तो नहीं होना चाहिए. Okay, so they are also saying that the hmm, resistance are same. No, we know the resistance is, so we can use it for the calculation. Okay, so rho, a resistance is equals to rho L over A. We have to use these two formulas. Okay, because we don't know the A and we also don't know the V, right? And the rest of the things are known, right? Rho, L, and N, they remain the same, right? N, Q, rho, and L, these are the four things that are the same, right? So if you relate R1A1 is equals to R2A2, right? So with the help of that, you can find the ratio of the areas, right? So R1 over R2 should be equal to A2 over A1, right? So R1 is, I'm taking B as R1. So, okay, so B has a resistance of 3, C has a resistance of 4. So 3 and 4, right? This should be A of B and A of C, right? So I'm getting 0.75 as the ratio of their cross-sectional areas, right? Now, since N and Q are the same, so you don't need to write it further, right? You can just use I1 over V1 is equals to I2 over V2, right? And we are interested in the drift speed of B, so I1 over I2. Acha, we have to include area by the way. So A1 and A2, right? So for the so I1 over I2 times A2 over A1 is equals to V1 over V2. Okay. Now just substitute the value. So I took 1 as B. Okay. 1 as B. Okay. So B has a current of 0.67, 0.6, 0.167. This is the current in B. Okay. And divided by the current in A is 0.25, right? So this is the ratio of the current. Now they're saying A2 over A1. A2 meaning area of C over area of B they're asking, right? So which is 1 over 0.5, right? because we found out area of B over C, but they're saying area of जो हमने formula में simplify किया, that is area of C over area of B, right? And that is equal to V1 over V2. Okay, please solve कर लो कितना आता है.
Sir, 0.89.
0.89 तो नहीं आना चाहिए. 3.
Yani, I'm sorry.
Wait. So ये हो जाएगा A2. A2 मैंने क्या लिया, A2 over A1. A2 over A1. Okay, fine. So this should be 0.5 only. 0.75, right? ये A B के चक्कर में ना सब कंफ्यूज हो रहा है. ये ले लो B, ये C, ये B and ये C, right? So हो जाएगा C over B, right? And यहाँ पे भी आप ले लो B, B and B, right? And C, C and C, right? So when you make the subject, let me just erase everything. So IB over AB, or IB over IC times AB multiplied by AC, right? AC. Perfect. And this will be equal to VB over VC, right? So IB over IC is fine. Fine, fine, fine. Now, कितना आ रहा है? How much?
0.5.
0.5, 0.5. समझ में आया? ये ऊपर से क्या?
समझ आ
Yes.
गया, sir.
Okay.
Yeah, but this all this for 2 marks should be like
Yes.
3 marks or something.
No, it should be three. It should be of 3 mark, but like they're just actually you just need to use formulas, okay? Like they're keeping everything same, so that's why they're giving you just 2 marks, okay? Like you can use this formula straight away, and you can use this relation straight away. So yes, okay, yes. Gulmin आगे चलो please.
A cell of EMF 1.5 volts and negligible internal resistance is connected in parallel with cell X.
हम्म. कहाँ गई?
Sorry, sir. Well, by shooting Maria
Fine.
is connected in parallel with cell X in figure 6.1 with their positive terminals together. State the change, if any, to the current in cell X.
Okay. In parallel. Hmm. So they're saying you are actually adding a 1.5 volt cell like this, yes? A cell of EMF is connected parallel with the cell X. Oh, okay, fine. State the change, if any, in the current and in the current X. State the change, if any. Cell X, okay, and the resistance C. Yes. क्या कहोगे?
पता नहीं, sir.
Okay. But so always keep in mind, whenever you use the two batteries in parallel, whenever you use the two battery in parallel, so the current will be exactly divided by 2, right? Look, if previously we were using the cell of 1.5, okay, and 1.5 volt cell produces 0.25 current in the circuit, right? So if you apply the battery of the same voltage in parallel with the 1.5, so Now both the cell will contribute equal amount of current such that the net current would be the same as 0.25, right? Is that clear, Bachu? Is that clear?
Ji,
Yes.
sir.
Okay.
Sir, but what if it's not 1.5 and something else?
Okay. This is not possible, by the way. Right. So if you connect the two cell in parallel like this, and let's say this is 1.5 and this is 1.51, this is not possible. This violates the Kirchhoff law, and if you do it in practical, it will explode the circuit, right? Because Kirchhoff law says any node, any junction should have the same voltage, right? So these are the junction, right? These are the two junction, right? And one battery contributing 1.5 volt at those two junction, and the other battery contributing 1.51. So where the point one difference coming from, right? So this is not possible. Okay, please keep in mind, in parallel, when you're connecting the two battery in parallel, the first condition that should be true as the two batteries should be of exactly same voltage, right? If point one, if they differ by point one, then they will just explode or like आग लग जाएगी circuit में, right? Is that clear, Imad? Right?
Yes, sir.
And this will help you, this will like this has the advantage of that the circuit will last longer, right? Because every battery is producing or is producing half of its energy in the circuit, right? So this is the usefulness of the connecting batteries in parallel, right? But if you connect the two batteries in series, then and also you are not allowed to connect in this combination, right? Otherwise it won't work, it will again just explode. Okay, so the two batteries should be in the same direction, and they should be of the same volt, right? So the parallel combination works, right? Otherwise it won't work, right? And it will last longer, it because every battery contribute half of the current, right? But in series, like if you connect the batteries in series like this, so you can either connect the two batteries like that way, and their cells, their individual voltage can be differ, right? And their orientation can also be different, right? And this will produce a greater voltage in a circuit, right? In a greater current, right? So if you want the greater power in the circuit, then you use the batteries in series. And if you want the circuit to last longer or the power supply to last longer, then you use parallel combination of the cell. Okay, is that clear, Bachu? So this will be half. Okay, the current. Look, they are asking for the current in the cell. Okay, so current in the cell X will be half. But if they ask you the current in the circuit, then the current in the circuit remains the same. Okay, what we calculated the value as 0.25, that should be the same, right? Because current in the circuit will be, or current in the circuit is decided by the resistors you have, right? If you increase or decrease a number of resistors or the values of the resistance, then current can be different, right? But if you're just varying the battery, then the net current should be the same as the previous case, right? The current will be half. And they're saying the resistor C has no effect on this. The cell will not create any effect on the resistor C. Okay, so no change, because they're saying that circuit के अंदर क्या होगा, so circuit के अंदर कुछ भी नहीं होगा, right? Circuit के अंदर current same रहेगा. Okay, perfect. Now let's try this. Okay, so Irfan, you sent me the question. The graph shows the variation of the displacement distance of the progressive wave at one instant. So they have given you the distance of the wave. The wavelength is 4 centimeter. Okay, the time period is 91 millisecond. What can you determine about the wave? So it has a velocity. You can do that. So one 1 over 91 exponent negative 3. So the time period of the wave is 10 11 11 hertz. Sorry, the frequency is 11 hertz. Okay. And um, okay, and the wavelength is 4 exponent negative 2, and divide that by 91 exponent negative 3, right? So the speed is 0.44, okay? What can be determined about the wave? I think it is transverse. You cannot say that it is a transverse wave. A longitudinal wave can also look like the same. If I'm getting. So C and D are
But
not
it's written a progressive wave.
progressive wave can be a sound now. You are saying so the sound is getting progressed or the energy in the sound is getting progressed so that I can hear you, right? Getting?
Oh yeah, okay. Okay, okay.
Okay. So option B and C and D are not correct. And option A is the correct one, I think. It has a velocity. I'm getting the velocity of 0.44 and the wavelength as point 4 and the wavelength is 4 centimeter, not 5, right? So A is the correct one. Clear?
Yeah. Also, this is one other question that a car travels at a constant speed of along a straight line PQ. Actually, you need the diagram first. So, should I send it at the end of the class? Or
It's up to you. You can send in the group so that the other student can also see.
okay.
Just send in the group or so as soon as we about to finish the class, I'll let you know. Okay. Let's move on. Imad, can you read the question, please?
Define electromotive force of a cell.
Hmm. Can you define it?
Sir, I think it converts electrical energy into different forms of energy. Hold
How?
up, sir, I don't remember.
ओए सो के उठ रहे हो अभी है ना?
G.
Nice. So uh, electromotive force is basically the work done from chemical to electrical energy energy per unit charge in a closed loop. In a closed loop. Okay, fine. Okay, let's move on.
A cell C of EMF 1.5 volts and internal resistance 0.2 ohms is connected in series with resistors X and Y as shown in figure 7.1. The resistance of X is constant and the resistance of Y can be varied. The resistance of Y is varied from 0 to 8 ohms. State explain the variation in the potential difference between points A and B.
Hmm. Between point in A and B. Okay, and you are basically the resistance of Y vary from 0 to 8. Hmm. So as you increase the resistance, the potential drop should be increased, right? Because um, if you use V equals to IR, okay. So when you increase the resistance value, so the current goes down, and if the current goes down, so the voltage drop across the internal resistance will also goes down. Okay, so there will be more voltage across the A and B, right? Or at and A and B, right? So we can say that um, increasing the resistance Y will decrease the current, okay, and decrease the current. Decrease the current. Allahu Akbar. And the loss and decrease the loss voltage. Okay. So the PD across A and B will be increased. Okay. Now let's move on. Yes, Imad.
The resistance of Y is set at 6 ohms. The current in the circuit is 0.1 amps. Calculate the resistance of X.
Okay. Resistance of X. Yes, what you do? This is a simple series
So
circuit. Hmm.
R equals V over I.
R equals to V over I. Okay. So what you consider R as? The X?
So what?
Yes. What will be your R?
Uh,
Okay, okay, fine. What will be your V then?
Sir, V will be same.
What,
I
which
didn't
value?
know.
Which,
Sir, I didn't know.
is it
Sir, we have
1.5?
to find individually, right?
Yes. Okay, use V equals to IR, right? You know that the total voltage is 1.5, right? But
Yes.
since it is a total voltage, then you have to use the total resistance of the circuit, which is 0.2, the internal resistance, plus X to be found, plus Y, which is 6, okay? And the total current, which is 0.18, right? Is that clear? Is the concept clear?
Sir, but how are you finding total resistance?
I'm just adding all of them because everything is in series.
Oh, okay.
Clear? You cannot say
Yes.
that this one is on the top of the Y, so it's parallel. Are you thinking that way?
No, no.
Okay, fine. So 1.5 divided by 0.18 is equals to 6.2 plus x. Okay, so you just take 6.2 to the other side minus 6.2. Yes, कितना आ रहा है?
2.13.
2.13. Fine, 2.13 ले लेते हैं. Fine, very good. Now, let's move on. The PD across
Yeah.
point A and B. Yes. Yes, math. What will we do at this point? You can use the ratio method, by the way, right? So you know that the voltage, which is 1.5, is the total voltage drop across the total resistance R total, right? Which you can say that as 2.13, right? Plus 6 plus 0.2, right? This is the total resistance. And since we are finding the resistance across, finding the voltage across X and Y, right? Because A and B is just X and Y, right? So you can say that 2.13 plus 6 is equals to X, okay? Just do the cross multiplication. So you'll get 8.13 times 1.5 divided by 8.25. 23, I think. Yeah, 33, 6.2, and 7, 8.2, 8.33,
So
yes.
you're getting 1.1.
1.1. Fine. Okay, now they're saying the efficiency of the cell. क्या करोगे?
So power output over power input.
अच्छा, by the way, wait. They are getting 1.46. Are you getting something like that?
Yeah, I got
So
1.46.
You were getting 1.46. Imad, आपने क्या किया? Irfan, did you try the same way or the other way?
I did ratio method. It's
Okay.
I added I just took 1.5 to 8.1.
Hmm.
What's it? 8.13.
Yes. 8.13 is just the combination of these two
Yeah, and then
divided by the whole thing, right?
yeah.
Okay, so it should be 1.46. Math getting? Are you getting the same answer?
Sir, I'm still getting 1.1.
Wait. 1.13 plus 6 plus point 0.2. Okay. Wait.
Yes, sir, I
1.5.
got 1.46.
Okay. Now, the efficiency of this cell. Okay. So there's some loss voltage, right? And the voltage drop across this one or the power drop across this resistor is the useful power. Okay. So we can say that efficiency is the useful power, which is the power drop across x and y, okay, divided by the total power x plus y plus the internal resistance small r, right, in 200, right? So now we know that I'm using for the power I'm using I square r, okay, divided by I square R, right? Since the circuit remains the same, so I and I get cancelled off, right? So in the numerator, I'll be left with the resistance of X plus Y, which is 8.13, and divided by in the denominator, the total resistance 8.33. Okay, just calculate the value.
Sir, 0.97. Samsung.
0.97. Ouch. Okay, fine. Perfect. 0.97. Now, let's move on to what is it? Mm, mm, mm. चलो ये कर लेते हैं. Irfan, please read the question.
Uh, sir, isn't it 97%? We have to multiply by 100.
Yeah, if you multiply that by 100, yes.
So if you write 0.97, will you still
Yeah, you'll get the
usually?
mark, but for that, you don't have to multiply. You don't have to show the multiplication with 100. Okay,
Yeah, okay.
clear. So if like we did show the multiplication with 100, so we have to write 97. Okay, fine. Now let's move on. Yes, Irfan, your turn.
Describe the IV characteristic of a metallic conductor at constant temperature.
Hmm. So basically, you just need
Which,
to define the graph.
sir, how do we know which one's output and input
Where? Over here.
in the efficiency?
Basically, the power, look, whatever the power drop or whatever the power transferred from this battery is the input, right? Okay. And whatever the power delivered to this point is the output, right? Is that clear? Because
Okay.
internal resistance are basically the losses, right? So this is the loss and this is x and y are the input or the output, okay, or the required, right? That is why. Now, and so you can also use the other formulas, by the way. Power is equals to IV. You can use it for the input power, right? And you can put 1.5 in it for the voltage, and for the current you can use 0.25, right? And that will give you the input input power, and for the output power you can use I square R, right? It depends, okay? It depends. So fine. Yes, Irfan. So
Semiconductor diode. Okay.
right. What about that one?
Sorry, I was
IV,
mecha.
look, IV
The thing
characteristic means
is,
you just need to define the graph, okay?
I get confused with the
Hmm?
the graphs mostly. It's V. There's VI also, right?
Yes,
VI
mainly
and
we
IV.
make IV graph, okay, mainly. But they
Mm.
they sometimes give you a VI graph, okay. So look, for the metallic conductor at a constant temperature, it just follow the Ohm's law. So it will be the straight line passing through the origin, okay. Whether it would be origin, whether it would be the IV graph or the VI graph for the first case, right? Okay, let's move on. Yes. Look, for the semiconductor, you should know that the IV graph looks like this. It will always be 0 in the negative direction and 0 in some volt in the positive direction, and then it go like this or like that, okay? Or if they give you the VI graph for it, right? VI graph, so the semiconductor look like this. Mm, this way and then like this, okay? So you can say that um, in the negative voltage mean when you are connecting it with the opposite polarity, right? Polarity of the battery, right? So in the negative voltage, the current will be 0, right? As well as few as well as in few positive voltage, right? This is for one mark, and for the other mark, you can say that um, the straight line with positive gradient for the rest of the positive voltage. Okay. चले भाई, let's move on. Yes, yes, Irfan.
Two identical filament lamps are connected in series and run in parallel to a battery of electromotive force 12 volt and negligible internal resistance as shown in figure 6.1a and 6.1b.
Hmm.
The IV
6.1.
characteristic of each lamp is
Mm-hmm.
shown in figure 6.2.
Okay.
Use the information shown in figure 6.2 to determine the current through the battery.
The circuit
Uh,
K.
this, yeah.
Yes. So they have connected a 12-volt battery, right? So you have to find out the current across that one, which is 4 ampere, 4.0. Right? Clear?
Yeah.
Hmm. Okay. The circuit, figure B. Okay. Okay. What to do with this one? So two identical lamps. So if two identical lamps mean both have the same resistance. So if they both have the same resistance, so 12, you have to add the resistance. So the IV characteristics of each lamp. Okay, fine, sorry. So for each lamp, there won't be 4.4 current. Okay. So since they're identical, since they're identical, so every lamp in the series combination gets 6 volt, right? Is that clear?
Yeah.
And every lamp in the parallel will get 12-volt drop across it, right? Because it is in parallel, right? So for the case of 6.1a, for each lamp there will be the current of this value, which is 2.2468, 2.8. Okay, is that clear? And the net current will also be 2.8 because it is a series circuit, right? And for the second case, you have to do it at 12, and then at 12 it is just 4. Okay, clear? Let's move on. Yes,
Calculate the total resistance in the circuit of figure 6.1a.
fine. So you have the voltage, you have the current. So just use V equals to IR, V equals to IR. So the voltage is 6 and the current is 2.8, right? So you will get the resistance and just times it by 2 to get both of the resistance. Okay, so it will give you just whatever the value,
4.285.
4.285, so 4.3. Okay, okay, let's move on. The circuit. Okay, now
The total resistance.
for this one, let me just wait. So for the current is going that way and 4 ampere of current is that way, right? So 12 divided by 4 equals to IR. 12 divided by 4 is equals to R, so that would be 3, right? And since we have two resistances of 3 volts, so 1 over 3 plus 1 over 3, so that would be 2 over 3, 3 over 2, 1.5. Okay, is that clear?
Yeah.
Fine. Now they're saying calculate the ratio for the power dissipated in the lamp. 6.1 in a lamp and in a lamp. Okay, fine. So you can use any formula. I'm using I square R for 6.1, and I'm again using I square R in 6.2. But since both are the different circuits, so you cannot cancel out any value of I or R, right? So I would be, for the first circuit, we calculated I was 2.8 to 2.8 squared, 2.8 squared, right? And the individual resistance was, it is 4.3 for the complete resistance. For the individual, it would be 2.15. Okay, and divided by I square R for the other one. So for the other circuit, we have the voltage drop. We have okay, we can so the what formula I'm using? Okay, so I square is basically I square is 4. Okay, and voltage is if you use a voltage, then it would be really helpful in this case. So I'm
It's
using
4 squared, right?
VI. No, no, I'm using IV instead of I square R. So 4 is the current and voltage is the 12, right? Okay, please find the value. Yes, how
I'm
much?
getting 0.35.
0.35. Okay, perfect. That's perfect. Now 0.35. I sent you guys the homework for this worksheet. Okay, so please try the remaining question. I'm leaving for the namaz, so I'll get back for with this question. If you know the solution, if whatever the question Irfan sent you, if you know the solution, the other guys can also text the solution in the group. Okay,
Sir, after Namaz, can you send this as PDF? Because I can't solve it as a Microsoft Word.
you can also you have the you have the laptop or tablet or
No, sir. Tablet.
computer, anything.
So I don't use laptop.
Neither computer.
No, sir.
Oh man, okay, I'll send you.
Okay, thank you.
Okay, okay, take care, guys. Love is
Enough.
Love it.
love.
No.
Sir,
Mm-hmm.
the that test, yeah, 12 out of 15 total score.
Mm-hmm. Nice, very good. So it's only the MCQ based.
Yeah, she said she's preparing for paper two, but That day
Okay.
she was quite busy, so she couldn't finish it.
Hmm. Fine, fine, fine. Perfect, perfect. Keep it a pro.
Okay,
Okay, well done.
that was.
Okay, laugh guys.